With section 1.1, which is on real numbers. So have you guys heard of rational numbers, integers, counting numbers? Have you heard that before? Okay. So some of this might be review. To some of you, it may be new. So I'll try to explain it as easily as possible. All right, so I created a Venn diagram. A Venn diagram is just basically a picture where you have like rectangles and circles, so you have sets within sets. So this first thing is real numbers. Now, real numbers at this point is probably all of the numbers that you can possibly think of right now. Okay, there are some other numbers called imaginary or complex numbers, but you've probably never heard of an imaginary number. Have many of you heard of that? No, okay. So probably anything that you can think of right now is a real number. And real numbers break into two categories, rational and irrational numbers. When you see the word rational, I want you to think of ratio. In other words, fractions, right? So this is any number that can be written as a fraction. Okay, so let's think about numbers. Can I write 5 as a fraction? 5 over 1, right? 5 can be written as a fraction. What about 0.3? Trick question, is that 1/3? Don't say 1/3. What is 3/10? Thank you. So 3/10. Can I write pi as a fraction? No. Okay, so rational numbers are going to be numbers like, you can write some examples, -1, 5, 0.3, 0.25, right? 3/8, like all of these would be fractions. These are going to include terminating and repeating decimals. So let's think of a repeating decimal, like 0.3 repeating. Can that be written as a fraction? What fraction is it? It is 1/3, right? Right, so anything that repeats or terminates, meaning stops, would be a rational number. Okay, but decimals that go on forever and never repeat, those are what we call irrational numbers. These are the ones that I think look kind of funny. Okay, so irrational numbers would be things like pi. It's like, wait, pi? That's a number? You guys all know pi is a number, don't you? I always celebrate Pi Day. Very important holiday. All right, so what else? Well, what about like square root of 2? Did you know that square root of 2 is a decimal that goes on forever but never repeats? Yep, any square root is like that. Well, I guess I should be careful saying that. What about square root of 25? What is square root of 25? 5. Does that go on forever without repeating? No. Okay, so that one would be a rational number. Does that make sense? So, but things like square root of 26, that doesn't have like a perfect, like the square root of 25 was 5. So that would be something like that, square root of 26. Or maybe you have cube roots. You probably haven't seen much with cube roots, but like cube root of 10, right? That would be an irrational number. Or combinations of square roots and fractions. Like maybe you have -3 square root of 2 all over 5. Right? The -3 over 5 part would be rational, but that square root of 2 makes it irrational. Okay, does that make sense? Did you know there's a number called e? Have you ever heard of that? Yep, there's a number that's called e. That's why in algebra, a lot of times we don't use an e as a variable. We usually use x's because a lot of these letters have things associated with them, like c. Do you guys know what c is? It's the speed of light. So usually when we have a c in there, it's the speed of light. All right, so all of those, see how they all kind of look funny? They don't look like real numbers, do they? They look strange. They are real numbers, but these are what we call irrational numbers. They are numbers that are, they are decimals that never repeat and never stop. So decimals that never repeat and never stop. So we would call them non-terminating, non-repeating. Okay, so from there, rational numbers. Well, there's certain types of rational numbers. Rational numbers break into another subcategory. Okay, so rational numbers could be broken into integers. Any guesses on what an integer is? No one knows? Yeah, what do you think?
Any number.
What do you mean by any number? Huh?
Any number above 0.
No? Yeah, what do you think?
Any number positive and negative that ends in a decimal.
Yeah, that's a good way of explaining it. So he says any number that's positive or negative that doesn't end in a decimal. So like the whole steps, like 1, 2, 3, 4, 5, but also they're negatives. -1, -2, -3, -4. What's a number that I didn't include when I gave that definition? What's the number between it? Right, 0. So we include that as well. So integers, I always remember that integers have NEG in it. So they include the negatives. So if you want to underline the NEG part. So it starts with, I mean, it doesn't really start with anything, right? So I do a ... on the end. So I'm signifying that it goes on forever to the left and to the right. Okay, so I include all of those whole steps. I do not include things like 1.2, right? They're only the whole numbers and their opposites. So that brings us to whole numbers. Whole numbers, the O is important. So for integers, I told you the NEG was important. Don't forget those negatives. Whole numbers, the O is important. Why do you think I circled that? Yeah?
Because whole numbers include 0.
So I do 0, 1, 2, 3, and so on. Perfect. And then natural numbers or counting numbers, these are the ones that were most natural for you to learn how to count. Now, wouldn't that be cool if I taught my little 3-year-old how to count and I was like, -5, -4, -3? Maybe that's not very cool, right? How do I teach my 3-year-old how to count? Where did we start? When you played hide and go seek, did you say 0, 1, 2? You started with 1. Does that make sense? So the natural numbers are the ones that were natural to learn how to count. They start with 1. So we sometimes call those the counting numbers. Okay, so does that make sense? So let's use this Venn diagram. So if I'm talking about, so you guys have the next little bit, if I talk about the number 7, I want to say all the different classifications that 7 is. So where I start for number 7 is in the most center that I can possibly be. I start here. It's a natural number, correct? Did you guys see it? 7 is a natural number. Now what else is it because it's inside that Venn diagram? It's a natural number, it's a whole number, it's an integer, rational, and real. It's a lot to write down, isn't it? So 7 is a natural, whole, integer, rational, and real. So we make sure that we read the instructions. So this says, classify the following numbers as real, rational, irrational, integer, whole, or natural. Circle the most specific answer. So what would the most specific one be? Yeah, what do you think, Maya? It's a natural number, exactly. So we're going to circle that one. And you'll have the same instructions on your homework. It will say, list all the things, circle the most specific. Now later on your homework, I do say something like, only give the most specific answer, okay? I've always had trouble saying specific since I was little. I have to like pause and think about how to say that. All right, pi. So what do we think? Looking at our Venn diagram, pi is an irrational number. All of these numbers that we have also have one more thing. What's the last one? Irrational and a real number. Yep, exactly. So irrational and real. All right, see if you guys can try the next one. So 1/2. Is it a number that we count, like a natural number? No. Is it a whole number starting at 0? Only the steps? No. Where does this one start? Yeah.
Rational.
It does. It starts at rational, exactly. So rational and real. All right, -0.4. It's a terminating decimal. It stops. So when we read that, we read it as 4/10, correct? So, well, -4/10. So it would be -4/10, or if I reduced it, it would be -2/5. We'll talk more about fractions later if you don't feel comfortable with fractions. So it can be written as a fraction, though. That's the most important thing. So it is rational and real. 22/7. Are you guys thinking pi? That's pi. Some people use that as an approximation for pi. It's not actually pi because pi goes on forever, right? And never repeats. This one does not go on forever and never repeat. I believe it is a repeating one. All right, so if I have 22/7, that is going to be rational and real because I can write it as a fraction, ratio, right? All right, now we have a weird one, cube root of 7. Remember I said the weird ones are what?
Irrational.
Irrational, right? But irrational numbers are also real numbers still. 8.3 repeating. Think about it. Can you write it as a fraction? Yeah, if you were writing it as a fraction, what would you do?
Oh, I was going to say irrational.
It is rational. Did you say rational or
No, I
irrational?
said irrational.
It's rational, yeah. What fraction is it?
Wait, repeated, would it be 1/3?
It's 8 1/3. Do you guys remember how to write that as an improper fraction? Like bigger on top than on the bottom?
Yeah, it'd be 24 over 3.
Close. 24 over 3 would be the 8. So if we want 8 and an additional 1/3, then it'd be
25.
25, right? So the trick for that, if you guys remember, is to multiply these first, 8 times 3, and then add the 1. And what we're literally doing when we do that is we're thinking of the 8 as 24 over 3, like you were saying, and we're adding the additional 1/3. That's where that's coming from. All right, so we get 25 over 3, which means that this is a rational number, and it's real. So don't be scared about the fractions. We're going to do a lot with fractions at the beginning. So if you don't know how to do that, that's fine. Hi. Yeah.
First period attendance, did you enter it in the
I took it. Everybody was here. Yeah,
And you did enter it in the system and it worked fine?
I think I did. Yeah.
Okay, thanks.
Hopefully I did. All right, next up, this is irrational and real because that's square root of 5, right? How about the square root of 49? What is square root of 49?
Oh, it's all of them.
Oh, be careful saying all of them because it doesn't include irrational, right? So we're going to start with natural, whole, integer, rational, and real. There are abbreviations for these things. I won't teach them to you though. I can next time. All right, how about this? 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2. Will that ever repeat? Yeah?
Irrational.
It is irrational. It's a weird number, and it's real. Okay, does that make sense? Do you guys understand that? Now, the next thing that you guys will have on your homework involves absolute value. Do you guys remember absolute value? Okay, it's the positive representation of a number. What it literally means is the distance, like the definition, the distance from that number to 0 on the number line. So that is a distance of 2 units. Does that make sense? So when I see absolute value of -2, it's really just 2. And then we'll also have graphing number lines. Okay, so we're going to stop here for now.